so we're having a look at this fraction a on b plus root c plus d on root c. Let's just rationalize this thing as we're showing this. Oops, we're showing this. It's all like nice and rational. So let's rationalize those these first. So I'll be timesing by that for this one, which will give me b squared minus c. Hope that's okay. We're just timesing top and bottom by b minus root c. And the other one we will be multiplying by root c, top and bottom. So we'll get that. So when we do put that together, what do we get? So we get our a... let's make a common denominator at the same time. So common denominator here would be c and b squared minus c. So here I'm actually going to times AC, I'm going to times the first one by c. And the second one, which is d root c, I'm timesing by that first denominator, which is b squared minus c. So you can see all together what we're going to get. So the first term is ABC, or ACB. We're going to get minus AC root c. We're going to get db squared root c and minus cd root c. And then all over our cb squared minus c. And then that would be ABC. Now these all have a root c in them, these three terms here. So I'll put a root c outside of. So there's the b squared d, which is positive. There's minus AC and a minus CD. Alright, hopefully I've gotten that kind of correct. Alright, so we want to prove that if this is rational, then this is b squared d is equal to, okay, so let's have a look at this. So first of all, we do know from the question c is not a square. C is not a square number. So when I square root c, I'm not going to get a nice integer. So for this to be integral, this whole thing to be, rational, we know a, b and c are positive integers, so that's all good. So this part is all good. And the bottom, we've got a... c is not a square. We also know that c cannot equal 0, otherwise we'd have a bit of a problem there. We'd be dividing by 0. And so really we need to get rid of this square root c business, because c itself is a positive integer. Square root c is not rational. So we need that to be 0, and we know that c can't equal 0 because of downstairs here. So that means I'm going to have to times it by 0. So that means this is going to have to equal 0. Now, that means b squared d minus ac minus cd has to equal 0. And if I rearrange that, I've got b squared d equals ac plus cd. And if I factorise by c, I've got c lots of a plus c. So I do get this, which is nice. So that definitely has to happen. Now, the other thing I can do is have a look at, if I rub this out, will I regret it? Let's see. So, hence, proof by contradiction that this is irrational. Alright, so let's compare this to up here, and you can see there's a 1 where the b is. So let's let b equal 1 to start with. When we do that, let's just check. We get a on 1 plus root c plus d on root c. So that's all good. We do get that. Now we just said that we're going to do it by contradiction. So we're saying suppose this is rational instead of irrational. Now if that's rational, remember we just showed that this, where b is 1, so that means that where b is 1, so if I put 1 squared d, c a plus d. So this has to work. D has to equal c lots of a plus d if this is to be rational. But what does that actually mean? That is, a plus d is a factor of d. That sounds a bit of a worry. A plus D is a factor of D. Alright, but this is impossible. Remember, our A and our C are positive integers, so there's no way that A plus D can be a factor of D itself. So by contradiction, then this must be irrational. Okay, hope that helps, even though I haven't written out the working.